we start with exercise 22A of the chapter Trigonometrical Ratios. Here we go for the first question and see we have been given with a right angle triangle with the two of the sides. First of all, we have to find the third side, and we will use Pythagoras theorem to find the third side. By Pythagoras theorem we get AC square equals to AB square plus BC square. And now we are going to place the values in AB and BC to find the value of AC. And by doing so, we have got the value of AC as 5. Now, we'll go for the parts of the question, and the very first of all part we have been given with sine A. And the sine A is perpendicular upon base. For this A, this will be perpendicular. Sorry, it was perpendicular upon hypotenuse. So for A, this one is perpendicular and this will be the hypotenuse. AC we have got 5. So we are going to first of all write the sides, that is BC upon AC. Then BC is 4 and AC is 5. And hence we got the sine A. Now we'll go for the second part, that is cos A. Cos A goes for base upon hypotenuse. For this A, this one is base and this one is hypotenuse. So it will become AB upon AC. And that is equals to 3 upon 5. Now the third part is cot A, which stands for base upon perpendicular. And here base is AB and the perpendicular will be BC. That is 3 upon 4. Now the next one is sec C, which goes for hypotenuse upon base. And for C, hypotenuse is AC and base is BC. So this will become 5 upon 4. Then the next one is cosec C, which goes for hypotenuse upon base. So for this one, hypotenuse upon perpendicular. So this one is hypotenuse and this one is your perpendicular. Now the AC upon AB, that will be equals to 5 upon 3. Now the last part is tan C, that is equals to perpendicular upon base, and for C the perpendicular is AB and the base is BC, and this will be equals to 3 upon 4. So here we see for the angle A, this was base, this one is perpendicular, and for the C, this is a perpendicular and this is a base. Now let's see question number 3. Here in this question we have been given with this figure in which two of the sides are missing. First of all this one and then this one. Now we are going to use Pythagoras theorem to find these two sides. First of all, we are going to find this side AB with the help of the Pythagoras theorem in the triangle ABD. And by using Pythagoras theorem, we have got the side AB as 5. That is hypotenuse square equals to perpendicular square plus base square. Then we have placed the values and solve for AB, and then we have got 5. Now similarly we are going to do for this triangle and find the value of CD. After the placing the values, we see that is we have to find DC square and it is lying on this one. So we are going to make a transpose and we can write this one as DC square equals to 12 square minus 4 square, that is 144 minus 16, and that will give you DC square equals to, and we finally get DC equals to 8 root 2. After getting this, we will go for the first part, and that is cos A. And for this angle, base is AD and this one is hypotenuse. So here we get base upon hypotenuse, that is equals to AD upon AB, and it will be 3 upon 5. Then we have cosec A, that is equals to hypotenuse upon perpendicular, and it will be equals to AB upon BD, and that is 5. Now let's do the third part. Then place the value of tan A, that is perpendicular upon base, and the sec A, that is hypotenuse upon base. And according to the angle A, the perpendicular is BD upon base. We are having AD. And similarly for the sec hypotenuse upon base, this will be the hypotenuse AB upon AD. Now place the values of this BD, AB and AD. Replacing the value and solving it, we get 16 by 9 minus 25 by 9, and that is equals to minus 9 by 9 equals to minus 1. Then we have sin C, which is equals to perpendicular upon hypotenuse. For the C, this BD will be perpendicular and this BC will be hypotenuse. That is equals to 4 by 12 and finally 1 by 3. Then we will go for the fifth part, sec C, that is equals to hypotenuse upon base, and for the C, hypotenuse is BC and the base is CD. And after placing the values of all, we have got this. Now this can be further solved and it can be written as 3 upon 2 root 2, and if we rationalize this, we get 3 root 2 upon 4. Then we have the sixth part, cot square C minus 1 upon sin square C, and this can be rewritten as cot square C minus 1 upon sin, that is the reciprocal of cosec. So it can be written as cosec square C. Now we place the values of cot C can be written as base upon perpendicular and cosec as the hypotenuse upon base. Then for the C, base is CD and perpendicular is BD, and this is the hypotenuse. We have just placed the values of hypotenuse, perpendicular, base. Now we have to place the values of all of the sides, and we have got this. Now we can solve it a bit. 4 2 times and here 4 3 times. Now 2 root 2 to the whole square is 8 minus 3 square is 9, and this will be equals to minus 1 as answers. Now let's see the other question. Now let's see question number 5. Here we have been given with sin A equals to 3 by 5. As we all know that sin A is perpendicular upon hypotenuse, so this can be written as perpendicular upon hypotenuse equals to 3 by 5. As the ratio perpendicular and hypotenuse is 3 by 5, so we can let perpendicular equals to 3x and hypotenuse equals to 5x. Then after that, with the help of the Pythagoras theorem, we can find the side, the length of the side, base. Now on applying a Pythagoras theorem, we have got the base as 4x. We have used hypotenuse square equals to perpendicular square plus base square. We have placed the values, and then from here we had made the transpose. On making a transpose and all, we have got 16x square, and then we have taken the square root on both of the sides to get the base b, and that is equals to 4x. I want to make one thing very clear over here, that you have to take x over here, that is 3x and 5x. Rather, your solution is not differed with the help of the x by taking x, but as this was a ratio p by h, which was 3 by 5, it was a complete ratio, therefore x is must over here, otherwise your answer will be considered wrong. Now I'll go for the first tan A, first part, that is equals to perpendicular upon base, and that is 3x upon 4x. We can cancel out the x and we'll be left with 3 by 4. Now let's see the second part of this one, that is base upon hypotenuse, and the base we have got as 4x upon hypotenuse we have taken as 5x, that is equals to 4 upon 5. Now let's see question number 10. Here we have 4 cot A equals to 3, and it can be written as cot A equals to 3 by 4. Now we all know that cot can be written as base upon perpendicular, that is 3 upon 4. Now let base equals to 3x and perpendicular equals to 4x. Now we are going to apply Pythagoras theorem to find the hypotenuse. Now on applying Pythagoras theorem, we have got hypotenuse as 5x. Now we'll go for the parts of the question. Sin A, that is perpendicular upon hypotenuse, and here the perpendicular is 4x and hypotenuse is 5x. We can cancel out the x and you will be left with 4 upon 5. Next one we have sec A, that is equals to hypotenuse upon base, and on placing the value and solving we get 5 by 3 as answer. Then in the third part we are having cosec square A minus cot square A, and after placing the value we've got h upon p to the whole square minus b upon p to the whole square. Then we get this, and on solving we get this one as the square as 25 by 16 minus 9 by 16. As the base is same, they can be subtracted directly and it will become 16 by 16, and that is equals to 1. Now let's see question number 14. Here we are having cos A equals to 1 by 2. We can do this question by the method as we were doing till now, but as 1 by 2 is the answer of the standard angle, we can use that method also. As 1 by 2 is equals to cos 60 degree, so we have replaced 1 by 2 by cos 60, and now as cos A equals to cos 60, this therefore A equals to 60 degree. Then the next one we have been given sin B equals to 1 by root 2, and 1 by root 2 comes with the angle of sin 45, that is equals to sin 45. Therefore B equals to 45 degree. Now we'll go for the question. Now we have this, so tan A equals to tan 60 minus tan 45 upon 1 plus tan 60 dot tan 45. Then tan 60 is root 3 minus 1 upon 1 plus root 3 into 1. After this we are going to rationalize this question. Now here, after multiplying by the conjugates, we have got this. Here we are having a plus b, a minus b in the form, so we got a square minus b square, and it was same, so it is whole square. Now open this one, and root 3 square plus 1 and so on, and here root 3 square will be 3, so 3 plus 1 4, and minus 2 root 3. Here we have solved 3 minus 1 to get 2. Then we have taken 2 common from these 2 upon 2, and this 2 is cancelled by this one, so we are left with this. Now the second part of the question is asking, are the angles A and B from the same triangle? We have to give the explanation for it. So here, as we see, the sum of A and B is 105, therefore it can't be angles of the same triangle. If the sum might be 90 degree, then it can be the angles of the same triangle. Now let's see question number 16. Here we are having tan x equals to 1 whole 1 upon 3, whereby we get perpendicular upon base equals to 4 by 3. Now we are going to suppose the perpendicular as and base as 4x and 3x. After this, we can take a Pythagoras theorem to find the value of h. So by Pythagoras theorem, we have finally got h equals to 5x. Then we'll go for the question which has been asked. Now we have to find this, and we are going to place the value of the sine as perpendicular upon hypotenuse, cos as base upon hypotenuse, and so on. Now we are going to solve them after placing the value. Here this x is cancelled out, and we are left with 4 into the square of 4, that is 16 by 25, minus 3 into 9 by 25 plus 2. Now solve this one. 16 4 is 64 by 25 minus 27 by 25 plus 2. And on taking LCM, and all, we finally get 87 by 25, and changing to mixed form, we have got this as the final answer. Now let's see question number 20. Here in this question we have been given with this figure, and here this side is 26, this one is 10, and this whole is 42. As this one is 10 and this one is 42, so this remaining BD will be 32. And now with the help of the Pythagoras theorem, in the triangle ACD we will finding this one, and then with the help of Pythagoras theorem in triangle ABD we can find this side. And here in triangle ACD we have applied Pythagoras theorem, and that is AC square equals to AD square plus CD square. On placing the values of AC 26, CD as 10, and on solving and making a transpose and all, we have got AD square as 576, and taking the square root on both the side, we have got 24 as the value of AD. Now we are going to use this AD in this triangle ABD to find the value of AB. And using Pythagoras theorem, we find the side AB with this triangle AD and BD. Now after this we'll go for the question. Then we are having the first part as cot x, and that is equals to base upon perpendicular. Now for the x, this will be the base and this will be the perpendicular. And on placing the value, we have got 24 by 10, that is equals to 2.4. Now the second part we are having 1 upon sine square y minus 1 upon tan square y, and it can be rewritten as cosec square y minus cot square y, as a reciprocal of 1 upon sine is cosec and the tan is cot. Now we are going to place the values. Now after placing the value, we'll see the y is over here, and for this y, this will be the base, this will be the perpendicular, and this will be the hypotenuse. So here it can be hypotenuse will be AB upon perpendicular AD to the whole square minus BD upon AD to the whole square. Now place the values and solve it. After placing the value, we have got this. Now 8 3s are 8 5s are again 3 and 4. Now make the square of it. It will be 25 by 9 minus 16 by 9, and equals to 9 by 9, and finally equals to 1. Now we are having the third part as 6 upon cos x minus 5 upon cos y plus 8 tan y. So very first of all, this can be written as 6 sec x minus 5 sec y plus 8 tan y. Now 6 sec is hypotenuse upon base, and for x, hypotenuse is this AC upon base is AD, minus 5 into, for y, hypotenuse is AB and base is BD. Then 8 into perpendicular AD upon base BD. Now we are going to place the values. Now on placing the value and solving it, we finally get 6 whole 1 by 4. That's all in this video. Thank you.